So the last conversion was not bad at all, but in the lab, right, we normally work with balances. So we normally actually work with weighing things out in grams. So we have to learn how to do mole-gram conversions. So we should probably go ahead and give ourselves, maybe we can look at that last chemical reaction, but ask ourselves how many grams would we make in the end. So here's our chemical reaction again. So that nitrogen plus hydrogen goes to ammonia. And maybe we want to know something like this. So for instance, if we had, say, 4.0 moles of nitrogen, and we wanted to know how many grams of ammonia would we make from that. So, oh gosh, how are we going to do that? Well, we can take our fingers again, right? We can say, so if we want to know how nitrogen is related to ammonia, right, we just need to find our fingers. And there's the ammonia, and there's the nitrogen. So that gives us one first conversion factor we can write. So our fingers tell us that 1 mole of nitrogen is equivalent to 2 moles of ammonia. How are we going to use this? Well, we can take our 4 moles of nitrogen, and we can convert it to moles of ammonia by putting the moles of nitrogen on the bottom, because then the units cancel, and the 2 moles of ammonia go on the top. And I don't even need a calculator for that. So 4 times 2 is 8. So that would be 8 moles of ammonia. And the question, though, did not ask us how many moles of ammonia, right? It said how many grams of ammonia. And so this means we got to do one more thing here. We got to take our ammonia, right? And we got to count by weighing. So the ammonia is made of 1 nitrogen and 3 hydrogens. And nitrogen, if we look on our periodic table, weighs 14.01 grams. Hydrogen weighs 1.01. Actually, your periodic table might say something like 1.00794 or something, but that seems like way too much work. So I'm going to round a little bit to 2 decimal places, I suppose. That gives us a grand weight of 17.04. So what does that mean? That means that, more usefully, to us, 1 mole of ammonia weighs 17.04 grams of ammonia. So, oh, that's so cool. We've got a conversion factor here. So we can use this conversion factor in the last step. We can take our 8 moles of ammonia and we can convert that to grams. So what goes on the top? What goes on the bottom? The moles of ammonia has to cancel, so it needs to go on the bottom. And that means, I suppose, that the other thing has only got one place it can go. So the 17.04 grams on the top, that mole we said earlier goes on the bottom. And that now gives us, when we punch it in our calculator, the answer. And I just punched it in on my calculator, and I got 136. And what are the units? They cancel out, so that is grams of ammonia. So 136 grams of ammonia, right? So this is a balance right here. So we could actually go ahead and we could weigh it out on there. So in the lab, right, we don't have things that weigh moles. We have things that weigh grams. And so balances are normally used for these kind of calculations. So let's try another one. So this is getting to be a little more interesting here. So how many moles of water will we make if we burn 8.54 grams of CH4? So that's methane. And here's how I like to organize my work here, because at some point, right, it gets a little confusing. So what I do is I take the 8.54 grams of methane, of CH4, and I write it here on the bottom of my problem. And what do I want to do? I want to go to moles of water. So I want to get all the way up here. And what I normally do is I kind of imagine, if you will, I've got 2 lines. Right underneath the chemical equation, I got moles. And a little bit lower, I've got grams. And my job is to get from one place to the other. So I got to do 2 steps here. This is like driving around the block. So we got to go up. And to get to moles, so we need to get the number of moles of CH4, right? So we've gone between our grams 2 moles by going upwards, I suppose. There's no way to go right down here, actually, and go grams to grams, so don't worry about that. And then we got to go one more step, right? So we got to go from moles of methane to moles of water. So let's try and figure out how we do those 2 steps. So we can go ahead and number them. And so that's step 1 and that's step 2. And step 1 requires us to go from grams to moles. So, we know how to do that. We need the molar mass of methane. So the molar mass is the mass that 1 mole would weigh. And we know how to do that. And how do we do that? We take the CH4 and we say it's made up of a C and 4 H's, and we can weigh that. So C is 12.01 and H is 1.01, and if you add those together you get 16.05, and that says that, or that tells us, I suppose, we have to know what it's saying, that 1 mole of methane weighs 16.05 grams of methane. So that's our step 1. Step 2 is moles to moles, and if you remember, moles to moles is where we got to use our fingers. So we've got moles of methane to moles of water. So let's see, there's the moles of water, and there's the moles of methane. And we can see our left-hand finger says there's 1 mole of methane, and our right-hand finger says there are 2 moles of water. So that gives us our second conversion. I'll write that in red. So we use the molar ratios. Those are from the coefficients in the balanced equation. So if it wasn't balanced, we'd have to balance it up, I suppose. And my left-hand finger says that for every 1 mole of methane, my right-hand finger says there will be 2 moles of water produced. And so that is my second conversion. So we should go ahead and put those two together. So let's go ahead and clean ourselves a little bit of space. So let's see, can I scrunch this up? Okay, yeah, I can throw it up like that. So there's my old work right there. So what am I going to do here? So I'm going to take my 8.54 grams of methane, and I'm going to do conversion 1. So there's a conversion factor. I got my molar mass, so I need my grams on the bottom, because they have to cancel out, right? So they have to give us grams no more, and leave us with moles of methane. So that is step number 1. So we did that like so. And then step number 2 is the mole-mole conversion. So this we'll have to be a little more careful about. 1 mole of methane, 2 moles of water. So since we've got our moles of methane on the top, our mole of methane will have to be on the bottom there. So let's go ahead and jot it down. 1 mole CH4 goes on the bottom. That means that the 2 moles of H2O have to go on the top. So that was the second conversion there. And if we look at those units, oh, they are so beautiful. So you can see those units, right? So we can pull out our red lightsaber, right? And we can say grams of methane canceled with grams of methane. We can say moles of methane canceled with moles of methane. And we can see that those moles of water are what our final units are going to look like. So we can go ahead now and run that calculation on our TI-83. And when you run that on your favorite calculator, it is 1.06 and a whole bunch of other digits. The first one is a 4. When we ran that off, we can just get rid of it. We have 4 sig figs right here. We have an infinite number here, and we have 3 here. So 3 is our worst case. So that's why we write our final answer to 3. And what were those units again? Oh, I suppose we need to get rid of those, right? So we cancel those, and we end up with those units right there. So 1.06 moles of water, and actually that was what the problem was asking for. So it would have been embarrassing if those units didn't match up. So nice, we're done.